Welcome to this explainer. Look, if you're a focused learner trying to break into or even just level up in the AI space right now, you are absolutely in the right place. Consider this your completely exclusive insider guide to surviving and conquering the 2025 LLM Engineer Interview Gauntlet. Because let's be real, the landscape is shifting incredibly fast. What easily got you hired last year, it probably won't even get you past a phone screen today. So we're going to break down exactly what hiring managers are actually looking for right now, based on the absolute latest data and strategies. Okay, let's dive into this. Landing an LLM engineer role in 2025 puts you at the heart of the generative AI revolution. The stakes right now are just massive, and naturally, the competition is fierce. Companies, they aren't just looking for someone who can theoretically explain how a transformer works anymore. They want engineers who can actually architect real-world solutions, navigate complex systems, and frankly, tame the wild, unpredictable nature of large language models in production.
To get you completely prepped, here is our roadmap. 1. Mastering core LLM fundamentals. 2. A deep dive into RAG. 3. Advanced prompt engineering mastery. 4. Model evaluation and hallucinations. 5. Real-world system design scenarios. And 6. Emerging trends for 2025. We're covering the whole shebang, from table stakes theory all the way up to macro-level architecture.
Starting off with Section 1, Mastering Core LLM Fundamentals.
So hiring managers are almost always going to start here, just to test your conceptual clarity. Before they throw you into the deep end of some complex technical problem, they have to know your foundation is rock solid. Honestly, if you stumble here, the interview usually ends pretty early. You're expected to know this baseline toolkit inside and out. We're talking tokenization, embeddings, and positional encoding within the transformer architecture. You need to casually and confidently discuss training paradigms, the nuances between supervised, unsupervised, and transfer learning. You'll also need to explain fine-tuning and domain adaptation, plus those prompt engineering basics like zero-shot, few-shot, and chain of thought. Oh, and don't forget the foundational evaluation metrics like accuracy, F1, and BLEU. But listen, here's the absolute critical part. Rote memorization, it is not enough. Any good interviewer will see right through a textbook definition. You've got to demonstrate exactly how you apply these principles to solve actual problems. Bring in examples from your past projects. That's how you prove you really get it.
Moving right along to Section 2, Deep Dive into RAG.
Retrieval-Augmented Generation is just a non-negotiable, must-know topic at this point. It has completely transformed how models access reliable, up-to-date information in production. So imagine you're sitting in the hot seat, right across from the hiring manager, and they hit you with this classic prompt. How does RAG architecture combine retrieval and generation? I want you to actively think about how you'd answer that right this second. Would you mention the specific components of the pipeline? Are you ready to talk about the real headaches of productionizing these systems, like dealing with scalability or handling messy retrieval errors?
Now, what's really interesting about this slide is how it perfectly maps out a winning interview strategy. Think of this as your mental cheat sheet for articulating trade-offs, which, by the way, is exactly what senior engineers are paid to do. Take that first piece on retrieval type. If they ask about dense versus sparse retrieval, your strategy shouldn't just be giving a definition. You need to jump into discussing hybrid approaches. Weigh the accuracy against the speed, the cost, the scaling. For evaluation, don't just lazily list rouge or blue. You want to cite a smart mix of automatic metrics, real user metrics, latency, and human evaluation. And when it comes to error handling, you have to confidently explain your fallback logic. What's your monitoring system going to do when a retriever completely misses the mark or gets some weird out-of-domain query?
Next up, Section 3, Advanced Prompt Engineering Mastery.
Let me give you a quick, fair warning right now. Simply knowing zero-shot and few-shot prompting, it's not going to cut it in a 2025 interview. The baseline expectations have just evolved way past that. Interviewers expect a massive leap in complexity from you. We're talking about the difference between basic prompting and advanced reasoning frameworks. You really need to demonstrate how you design multi-step prompts for complex reasoning tasks. You should be highly fluent in advanced concepts like self-consistency, tree of thought, and React frameworks. Plus, you should absolutely expect questions on prompt injection risks and defenses, and exactly how you'd set up prompt A/B testing and online optimization to balance speed with accuracy.
Section 4, Model Evaluation and Hallucinations.
It is one thing to get a model to generate some text. It is an entirely different beast to actually trust that text. Hiring managers heavily favor candidates who know how to iterate, measure, and safely improve prompt performance in a live production environment. A massive differentiator here is just knowing your tooling. An evaluation harness, for example, is a framework that lets you systematically test and benchmark LLM prompts, models, and outputs across tasks. Think of Eleuther AI's LM-evaluation-harness. Using tools like this ensures consistency and reproducibility. Framing your answers around industry-standard tooling is a huge, high-value takeaway, mostly because a shocking number of candidates fail simply because they don't even know these systematic frameworks exist.
And obviously, you're going to get asked about hallucinations. You have to break this down logically for them. First, show them you can identify the root causes, things like overgeneralization or insufficient context in the prompt. Then, immediately pivot to your mitigations, like bringing in retrieval, augmentation, or refining the prompt itself. Finally, bring it home by explaining how you'd build external validation pipelines to catch the errors before users see them. Tackling hallucination control head-on just proves you're a practical, production-minded engineer.
Moving to Section 5, Real-World System Design Scenarios.
And this brilliantly illustrates a recurring interview motif. The interviewer has tested all your theory, and now they want to see you architect a living, breathing system. Something like this scenario. Design a RAG-powered customer support chatbot. It sounds so simple on the surface, right? But it's actually an incredibly deep well designed to test your architectural thinking. So how do you actually build it? You have to walk the interviewer step by step through the architecture. Step 1, implementing fallback logic for failed retrievals. Step 2, detecting and mitigating domain-specific hallucinations. I mean, what if this chatbot is for a medical or legal company? Hallucinations there are catastrophic. Step 3 is architecting the system to handle scaling inference up to millions of users. Step 4, integrating a prompt optimization feedback loop so it actually gets smarter. And Step 5, setting up continual evaluation and retraining. To really get comfortable with this flow, our source material highly recommends checking out tools like Huru.ai. It lets you simulate these exact system design interviews and gives you instant AI-powered feedback on your explanations. Honestly, practicing these steps out loud is vital.
Finally, Section 6, Emerging Trends for 2025. Let's move to and see how this builds your profile as an elite candidate. This is where you prove that you aren't just coasting on today's tech, but that you are entirely future-proofed. You need to be totally ready to discuss agentic frameworks, things like action planning and compositional reasoning for the next generation of apps. You should definitely understand how to use LLMs for legacy system integration, all while keeping data privacy and security front and center. You need a solid grasp on multimodal LLMs that fuse text, images, and tabular data like GPT-4v and Gemini. But above all else, you need to demonstrate continuous learning strategies. That shows a mindset for ongoing, relentless improvement, and that is exactly what hiring managers desperately want on their teams. So, the crucial point is this. Technical knowledge, it's just the baseline now. The absolute best LLM engineers out there aren't just technical. They are strategic, they're communicative, and they are massively growth-oriented. They clearly understand how their models impact the broader business goals. So, knowing all of this, how are you going to showcase your true impact in your next interview? Take these strategies, practice them relentlessly, and go completely crush that interview. Thanks for joining me for this explainer, and keep learning.